Hey guys, welcome to Apna Guruji. This is Surjit Paul and we are going to study about physics class ICSE 10 and we are starting with the first chapter, that is force. So before going to the chapter, I have to say that this is the rocket series of Apna Guruji, and in this rocket series we are going to complete the whole syllabus of physics of class ICSE 10 within a certain period of time, so that you can get a time for your revision and for your practice. So I will try to make this video in shorter duration so that you can easily understand all the concept of the chapter in a short duration of time and more carefully. Okay, so first the topic is our force. So first thing you have to understand about that, what do you mean by force? So simply force is a pull or push. Whenever whatever the things we can apply some, we can do some push or pull whenever we are open a cap of a marker, when we are eating some food, when we are lifting something, when we are kicking a football, every time we are using the force, and that force is simply can be stated as pull or push. So you can simply in a simple term explain that what is force. Force is simply pull or push. In the previous classes in 8th, 9th, 10th, you already studied about the force and force definition, that force is a agent that causes the changes in motion, that causes the change in shape, that causes the change in the direction, or all over the things that is done by the force. So we are in the class 10, we are going to study about the force in some higher manner, that is force. So the first you have to learn about, before going to force, and the formula of force. In particular class we are using the formula of the force and have to do some numericals also based on the formula. So before going to the formula of the force, we have to understand about the momentum. So momentum is simply stated as the amount of motion contained in a body. So the amount of motion contained in a body, that is known as the momentum, means how much amount of the motion that body has contained, and the symbol of the momentum is given by P, and this is a vector quantity. You know that the vector quantity, all those quantity which have both magnitude and direction, that are known as the vector quantity, and momentum has both magnitude and direction, so that's why momentum is a vector quantity. And the formula of the momentum is given by mass into velocity, and velocity we know that a vector, that's why momentum also a vector quantity. Okay, so about the SI unit, that mass unit is kg, and this is meter per second, that SI unit will be kg meter per second. That is the SI unit of the momentum. And then after we know the second law of motion, that is second law, or Newton's second law state that the rate of change of momentum is directly proportional to the applied force. Suppose this is the body, and we are applying some force upon this body, and the body will move, and the change in the momentum is directly proportional to the applied force. Suppose the initial velocity of the body is u, and after applying the force, the body is changed to velocity of v. Okay, so let us consider the mass is m. So its initial momentum will be mu, and its final momentum will be mv. So the change in momentum will be mv minus mu. So the second law states that the rate of change of momentum is directly proportional to the applied force, that is force is directly proportional to the rate of change. Rate means that with the change in the momentum with respect to the time, that is mv minus mu by t. So we can write this as f. After removing the proportional, we have to multiply a constant, and let the constant will be k equals to k mv minus mu by t. So by the equation of motion, we know that v equals to u plus at. So we can write v minus u equals to at, and then v minus u by t equals to a, that is acceleration. And we can simply simplify this, f equals to k m v minus u by t, and we can replace f equals to k m a. So we can consider the constant value equals to 1, we will get that force equals to mass into acceleration. That is the formula of the force we can obtain from the second law of motion, or that Newton's second law, and the unit of the force is Newton. The students don't forget to write the unit, because the unit is very important in physics. So this is the second law, this is the formula of the force, and we can simply state that the force equals to mass into acceleration. If in the question you have given the mass of the body and acceleration of the body, you can simply write the formula and get the answer of that amount of force or the magnitude of force. And now we know that force is also a vector quantity, because force is also a magnitude and direction, because acceleration is a vector quantity, that's why it's also a vector quantity, but mass is a scalar quantity. So after this we have to know about the next term, that is impulse. So you can write your copy, you can pause the video and write this if you required. Then is our next term, that is impulse. Impulse. So impulse is simply the change in the effect or the measure of the total effect by the force. The impulse is simply the measure of total effect of the force. Suppose we are applying some force upon a body and some effects, its motion is changing, its position is changing, its speed is changing. Okay, so that measure of the effect is known as the impulse. So impulse can be written as force into time. The impulse is depend upon the amount of force is applied upon the body, and the particular the time duration. It is depend upon the time duration, because the total effect of the force means the total effect will be obtained by the time that the force is applied upon the body. Okay, so that is the impulse. So after this, suppose this is a plane surface and there is an object, and we are applying force upon this body in this direction. Applied force in particular direction to this direction. Okay, so whenever there is an object, it is applying some force. That means doesn't mean that a single force is acting upon it. Whenever there is a object in physical or 3 dimension, there a multiple force is acting upon it, because when we applied force upon this direction, a frictional force will be acting upon the opposite direction, that is frictional force. And in the downward direction, because the body has some mass, and we know that a gravitational force is acting to the downward direction, that is the mg. This will be the acceleration due to gravity of value of g, and that will be the downward force or the force due to gravity, and there will be a normal reaction in the upward direction also, normal reaction. So this force is acting due to the third law of motion. We know that there every reaction is the equal and opposite reaction, that applied force and reaction force will be equal, and mg normal reaction will be equal. Okay, if the body is in a balanced condition. Okay, then after in our class 10, that is a very important topic, that is torque or the moment of force. Basically your questions are given from the torque topic, not from these topics, because you have important topic, that is torque, or we can simply state as is moment of force. So moment of force means simply the rotational effect produced by the force. Suppose a body is there, and we are applying force upon this, and the body is rotated, so that effect is known as the moment of force. So whenever we are opening a door or closing a door, so we are applying force and the body is rotating, so that effect is known as a torque. Whenever applying some force upon a body and the body get in rotational motion, so that is your torque or moment of force. So in the torque or moment of force, suppose this object, so there is a rotational axis of rotation, and here we are applying the force in this direction, applied force. So the body will rotate in this particular way, that is the anti-clockwise direction, anti-clockwise rotation. And suppose this is the object and this is the axis of rotation, and the force is applied to this direction, the body will rotate in this direction, so that is the applied force. applied force, and this is the clockwise rotation. Clockwise rotation. Clockwise rotation. This is the clockwise rotation. So we can obtain the force of the torque, that is we are applying the force and the body get displaces. So this torque will be, the symbol of torque is given by this, and the formula of this, that applied force and the perpendicular distance. So the perpendicular distance means if we are applying the force here, so the distance from the axis to the applied force, that distance is known as the perpendicular distance. If the distance is less, okay, we are applying to this point, the rotation will be less, and if the distance is increasing, that rotation will be increased, because we can simply write that torque is directly proportional to force and torque is directly proportional to the perpendicular distance. So if the force is increasing, the torque will be increased, and if the force is decreasing, the torque will decrease. If the distance perpendicular distance is increasing, then the torque will be increasing. If we simply, this is that this is considered, this is a object and it is the axis of rotation. If we apply force upon this place, the rotation will be more. If we apply a force on this place, the rotation will be less. So you can do it practically in your home by opening or closing a door and slightly changing the distance. So you can easily feel that the rotation. Okay, this is the torque, and the unit of the torque will be, for the unit of force is Newton and the distance unit is meter. So that is Newton meter will be its SI unit. Okay. So then come to the topic couple. Okay, couple means two moment of force at single point. Okay. So couple means it have two moment of force. So this is in the center, that is the axis of rotation, that is the axis of rotation, and we are applying force upon this direction in this place and force upon this place. So there will be a perpendicular distance, there will be a perpendicular distance. Okay, so this is F1 and this is F2. Okay, this is center O B A. Okay, so in particular this place, the moment of force torque 1 equals to will be F1 multiply OB, and let this is T2, torque 2, that is F2 multiply OA. Okay, so the couple will be either force into, okay, the couple will be sum of this T1 plus T2, and that is F1 multiply OB plus F2 multiply OA. So you must remember that for the couple, the F1 and F2 must be equal. F1 and F2 must be equal, because the couple only can be sent when the efforts of the two forces are equal. Couple does not obtain by effort of a single side. The effort should be equal from the both side. Okay, so that F1 and F2 will be equal. So we can simply write that couple equals to F either force multiply OB plus OA. Either force and the distance between the 2 points, that is your couple. Okay, so main thing here, remember that couple will be satisfied in equilibrium case, that is clockwise movement equals to anti-clockwise movement. This is the main thing in the couple, means the clockwise rotation movement must be equal to the anti-clockwise movement. For this case, you need to have the equal amount of force applied on the both sides. Okay, or in some cases you can change that. That does not mean that the force will be equal. The product of the force and the distance will be equal. Then can the couple can be done. Suppose in case the force is more but the distance is less. In case you have to only identify the clockwise movement equals to anti-clockwise movement. Then only it is in equilibrium condition, rotational equilibrium. So that is about the couple. So based on these topics, you have the important on the torque and or the moment of force and the couple, and you have to solve various numericals on this basis of the concept. So in the next lecture we are going to solve numerical based on the couple and the moment of force, and then we have to discussion about the center of gravity. Okay, so for this class we have read about the force, the definition of force, the formula of force, torque and the couple. So if you new to the channel, then subscribe our channel, and for this amazing lectures on physics of class ICC 10 and many more. So stay tuned and subscribe our channel. Let's meet in the next video. Thank you very much.